Right, so last time we went over the fundamentals of what vectors are. This time we're going to do a few examples involving proofs as well. So the first example here is we're given this geometric formation, and we're told that A to B is 3A. That's what this arrow means. So going from A to B is 3A. So we can write that down. A to B is 3A. And we also know that A to C is 4B. We can also write that down. So that's what we know. We also know that the ratio or point D lies on the line BC such that BD to DC is equal to the ratio 1 to 3. So we know that so we kind of have an idea of where D is placed on this line. And what we want to do is we want to find AD. So let's think. So the first thing that I do is, because obviously we can't find the direct route, we can't find this line here from A to D. We need to figure out how to get from A to D using the information we have. So I'm thinking about the different paths I can take. So I can either take this path from A to B and then go to D like that, or I can take this path, A to C, and then go to D from that. What I'm going to do is I'm going to take the path from A to B and B to D, but either will work. So what we can do is we can write A to D as a composition of these two vectors. So first you go up from A to B, and then when you get to B, you go to D. So it'll be plus B to D. And now we've converted this kind of unknown vector here into two vectors we can figure out. So AB is something we already know. We know it's 3A. But BD is a bit more complicated. So the thing is, BD is this vector here, that one. We don't know BD, but we know where it lies on BC. So let's try and figure out what BC is. Well, again, we don't really know how to get directly from B to C. We don't know this vector. But what we do know is that we can still get from B to C using another path. So what we can do is we can actually go back to A and then go to C. So what we can write BC as is you can write it as BA plus AC, like that. And now that'll equal, in fact, let's do it here. BC will now equal, well, BA is just the negative of AB, so it'll be minus 3A, plus AC, which is, we know up here, it's 4B. So we know what BC is. So now how do we find BD from BC? Well, what we do is we know this ratio then. So we know that BD, which is this line here, is BD. Oh, yeah, let's, not the vector because it wouldn't have two arrows, but this is just BD. And this is DC. And we know that BD is, for BD to DC is 1 to 3. So for every 1, this will be 3 times that. So if we take this as 3 units and this is 1 unit, we know the total amount of units, so BC will be 4, right? but we only want the one unit. We only want BD. So what we can do is we know that BD is a quarter of BC. That's what we can figure out, because again, all of BC is, if all of BC was 4 units, BD would only be one of those units. Now, we don't know what the units are, those are just arbitrary, but the point is, whatever BC is, BD will be a quarter of that. So that's why we can figure this out. And then, well, we know what BC is, so we can actually substitute this into the equation. So we can substitute BC in to get, whoops, this. And if we go up here, we can expand the brackets. So we have minus 3/4 A plus B, like so. Okay, so then now that we know what BD is, we can put it back into our original equation that we were trying to figure out over here, and we'll get that AD is equal to AB plus BD. And we can tidy this up a bit to get 9/4A plus B. And that is AD. So these kind of questions, the best thing to do is see, can I work this vector out using the information I have? If you can't, then you try and find another path that's not direct. And then once you found that path, which we did here, check if you can, check if you know these two vectors. If you don't know one of the vectors, try and figure that vector out over here. And then keep doing that until you find one of the vectors you need, and you can work your way back up and solve the original equation. Now, there are also a few proofs you'll need to know. You'll need to know 2 things. You'll need to prove if 2 vectors are parallel. And you'll also need to prove if points are collinear. So I'll explain these in more detail now. So first off, if we want to prove if 2 vectors are parallel, we need to show that they are multiples of each other. So, for example, we could have the AB equals 1/2 BC, or let's say CD. If we know that, then because CD is a multiple of AB, then we know that they're parallel. AB and CD are parallel. Now, collinear just means that they lie along the same line. So you'll usually be given 3 points, and you have to show that they lie on the same line. So what you need to do here is you need to show that they share a point. Sorry. They share a point and are parallel. So this is tougher to prove. because you need to show that that they share a point, and then two vectors that connect those lines together are parallel. I can write vectors that connect lines. So you need to show that they're parallel and they share a point. And the reason this works is because if you have two parallel lines like this, if you show that they share even one point, they've got to be on the same line, because you're talking about the same line if you're talking about two parallel lines that share a single point. It doesn't matter if you don't understand how that works, but it should give some intuition into how why we use this to prove collinearity. Now here is an example that uses these ideas. So first off, we know that O to A, so we can write that. So if we write A, so we know O to A is equal to 2A. And we know that O to C is equal to B. We know that AB is parallel to OC. So in fact, we can draw these in. We can show that AB is parallel to OC, like that. And we know that they're parallel because OC is a multiple of AB. And you can see that OC is 3 times the amount of AB. Oh, sorry, AB is 3 times the amount of OC, because you need 3 OCs to get an AB. And now what we want to do is we want to find expressions for OB and AC in terms of A and B. So let's do that. So OB, again, we don't know this direct vector. So let's think of the path we can take. So we can either take this path here, which will go from OA to AB, or OC to CB, because we don't know what CB is either. So we can't really use that path. But what we can do is we can use this path, because we know because AB is 3 times OC, and we know that OC is B, we know that AB must be 3B. In fact, you can just substitute this into here. Just put B into there and we get AB is equal to 3B. And what we can do is we can write that down. Yeah. So now we know what OB is. We're going to use OB, going to set OB equal to OA plus AB. And that will equal 2A plus 3B. That's our answer for OB. Now the second thing it wants is AC. Okay, so let's have a go at that. So AC is this point here, oops, to here. And again, we don't have a direct route, so we need to find another path. Now, again, we don't know BC either, so this path would be more difficult. But what we can do is we can go from A to O and then O to C to get from A to C. So let's try that. So we say that AC, sorry. In fact, I'll do it here. We say that AC is equal to AO plus OC, like that. AO is minus 2A because we're going in the opposite direction, plus B, which is OC. So that's our answer. We get minus 2A plus B. Okay, so that's question A done. Now we're given a new piece of information here. We're given that a point P lies on AC such that AP to PC is 3:1. Well, let's draw that in. So P would be around here, let's say. And again, we have the ratio 3:1. So we know that any point along here will be 3 times any length here. So that's what we can say. And in fact, we can deduce from that, if we really want to, that AC is equal, or AP is equal to 3/4 of AC, and PC is equal to 1/4 of AC. That makes sense because AC is this whole line and it consists of 4 parts, 3 and 1. The vector AP consists of 3 out of the 4 parts, and PC consists of 1 out of the 4 parts. So that's why we get 3/4 and 1/4. So that's how that works. And now it says find expressions for the vectors AP and OP in terms of A and B. Well, in fact, I've already found AP through that explanation. But OP, now, we can find OA to get back to this point, and we can go for find AP, which we already know both of these. So we get OP equals 2A plus AP, which we figured out to be 3/4 AC, which AC we've figured out to be minus 2A plus B. In fact, I'm going to have to rewind a bit here because it wants it in terms of A and B. So AP would not be the final answer. That wouldn't be the final answer because we need to convert it into terms of A and B. So we know AC is minus 2A plus B. So AP will be minus 3/2A plus 3/4 B. And you can check that if you need to, like when I expand the brackets out, that's what I get. So that will be your answer for AP. And we don't need to bring it in like this now. We can just bring it in from our answer. So we get plus 3/4B minus 3/2A. So then we get it to equal 1/2 A plus 3/4 B. So there, we've managed to successfully find AP and OP. All right, so finally we have C. Now C says, from this information, prove that point P lies on the line OB and determine the ratio OP to PB. Okay. So what we want to do is we want to show that this that P lies on this line. Now I know that's not a straight line because this diagram isn't to scale, but we want to show that P lies on the line OB. We'll move on to this ratio bit afterwards. So first off, what we want to do is we know that OB equals OP plus PB, because we have OP to here and then PB to here. So that'll give us the line OB. Now what we want to show is that these points are on the same line. So what we can do is if we show that OP and PB are parallel, that's how we'll get our answer. So if we go back here, remember, we're looking for two vectors that are parallel and share a point. So here, these two share the point P. So if they're parallel, then OB will just be OP and B will lie on the line OB. So let's figure it out. So we know that OP already equals a half A plus 3/4 B, like that. PB, on the other hand, PB we need to find out. So what we can do is we obviously don't have the direct root, but what we can do is we can go back to A like this, and then we can go to B. So PA will be the negative of AP. So we know AP is this. So the negative of that, so let's write PB as PA plus AB. So PA will be the negative of this. So it'll be 3/2 A minus 3/4 B. And we know that AB is 3B, like that. So we get PB to equal 3/2A minus 9/4 B. I'm just gonna quickly check that. Yeah. Okay. So let's see if they're parallel. So the way we can do this is if we multiply OP such that this A becomes equal to this A, we should get this B equal to this B. So the way we can do that is that we can, this will be a plus, yeah. So what can we do to get OP to PB? Well, we can actually multiply OP by 3, can't we? So 3OP will equal, well, let's multiply that by 3. So we've got the same amount of A's, and now we just need to check if we have the same amount of B's. Well, 3/4 times 3 is 9/4B. So that's the same as PB. And we've shown that OP is a multiple of PB. So these two are parallel, and since they share the point P, then you know that they're collinear. Another set of points you could have done is you could have done OB and OP, and that would have been easier because you know OB and you know OP. So what you could do is you get the same answer, and they share the point O. And similarly, you could do OB and PB. The reason I opted to do this set of vectors is because the second part of the question asks to determine the ratio OP to PB. Well, we've actually done that here. We know that OP is 3 times PB. So PB is 3 times OP. So that will be equal to 1, 3. That's our ratio.